and welcome to the video about proving how the inscribed angle with the non-diameter vertex is always half of the central angle of a triangle in a circle. Also known as, in this case, how this inscribed angle over here is always equal to 90 when the central angle is equal to the diameter of the circle. Okay, so we know that half of the diameter of the circle is the radius. Therefore, this is the radius, this is the radius, and this is the radius. So now, if that means they're all equal. So if these two are equal and these two are equal, then that means we have ourselves two isosceles triangles. Since in an isosceles triangle, two of the sides are equal. Also in an isosceles triangle, the two angles are equal. So this angle and this angle are equal, and these angles over here are equal. So we'll call these x and these y. In a triangle, we know that all the angles add up to 180. So one angle plus another equals 180. Now, in order to prove that this angle over here is in fact 90, we must find out what these two angles are equal to, angle A and angle Z. Since we know that the sum of the angles in a triangle is 180, this angle would be 180 minus 2x, since the other two angles add up to be 2x. So this is 180 minus 2x, and angle A would be 2x because it is the supplement of angle Z, so it has to be 2x since angle Z is 180 minus 2x. So when we're applying to this situation to actual numbers as angles and not just variables, you'll realize that angle Z is also equal to 2 times this angle Y. It'll be much clearer when we get to the example. So now with the information we have, let's try to see if we can prove that this angle is in fact 90 degrees. So we know that in an isosceles triangle, this angle plus this angle plus this angle equals 180. So we would get 2x plus 2y equals 180 as an equation. So now if we divide each side by 2 to simplify, we get x plus y equals 90. Now let's take a look back at our triangle. And what do you know? X plus y does in fact equal 90. And that's how we can prove for sure that the inscribed angle with the non-diameter vertex will always equal half of the central angle, which in this case is the diameter of the circle. So now let's have an example. Since all of the angles in a triangle add up to 180, we know that this angle will be 180 minus 20 plus x, and this angle will be 20 plus x. So, since it's a supplement of this angle. So now, since these triangles are isosceles, these two, we also know that angle x will equal to 20 because those two angles are the same. So, x equals 20. This gives us the equation for angle z, which is 180 minus 2 times 20 equals z. So we simplify once to get 180 minus 40 equals z. Then we simplify again to get 140 degrees equals angle z. So now, if you take a closer look at this triangle, you'll realize that this 70-degree angle over here is in fact half of angle z, as I mentioned it would be before. So technically, you could solve all of the angles in these two isosceles triangles just by knowing that this one is 20. But we'll just use the 70 for now because it'll be easier to understand and it'll make it simpler. But remember that in every single situation, this angle over here will be half of angle z or whatever variable that's representing it. Okay. So now let's get back to what angle z is equal to. So we said it was equal to 140, and to make sure, we'll do a check. So 140 plus 20, and this angle also, which is 20, will equal 180. So we are in fact correct that angle z equals 140. Okay, so now for the other isosceles triangle, let's do the same thing. So we know that y equals to 70 since it's an isosceles triangle and these two angles are the same. So then angle A would be 180 minus 2 times 70 equals A. And then when we simplify, we get 180 minus 140 equals A. And then we end up with 40 degrees as angle A. Now we could do that, or we could have also done 20 plus 20 equals 40. And we could have done this because we know that since angle A is a supplement of angle Z, it would be equal to 20 plus x, and we also know that x equals to 20, so technically it would be 20 plus 20. And that's how we got that equation, 20 plus 20 equals 40. So now let's do a check. 40 plus 70 plus 70 equals 180. That is in fact correct. And if you don't believe it, you could just take your handy dandy calculator, but that's not very necessary because it's very mentally possible to do this in your head. Okay, so you would do all this if you wanted to find out all of the angles in these two isosceles triangles, or even if you just wanted to prove that the 70-degree angle was half of angle Z. However, if you just wanted to figure out what this angle was, or to prove that this angle is 90, all you would do is this process. X plus y equals 90, as x plus y is in fact equal 90. And we know that x equals to 20 and y equals 70. So we'll end up with 20 plus 70 equals 90, which will give us 90 equals 90. So that's how we prove that this angle equals 90 degrees all the time if the central angle is equal to the diameter of the circle. Thank you for listening. I hope you understood, and have a good day.